Hello everyone, welcome back. It's Paul Tilley again. Today we're going to talk about annuities due. Annuities due are simply annuity payments that are made at the beginning of the period. So let's take an example here. I have a simple example of a timeline. So far, what we've done when we looked at annuities is annuities have always been paid at the end of the period. Let's assume that it's a year here. Let's assume that it's a year. So in a normal annuity, what happens is the payment is made at the end of the period, the year. With an annuity due, that situation is turned on its head. What happens in an annuity due is the payment is made at the very beginning of the period. So the thing is with this is that because it's made at the beginning of the period, there is an initial payment made up front. Every other one then occurs at the beginning of each successive period. Now the thing is, why are we dealing with annuities due? Most financial transactions like lease payments, rent, equipment payments, anything dealing with real estate tend to be payments that are made at the beginning of the period as opposed to the end of the period. So when we're talking about an annuity, we're talking about a string of payments, equal payments, that are made at given intervals in time. So it's important to be able to understand how to calculate an annuity due. In order to calculate an annuity due, it's basically very similar to other annuity payments. So essentially, what we have is the same as the annuity payment calculation, but we add one little component, and that is we take on this multiply by 1 plus the interest rate. So this section right here is a significantly different part on the equation. It's the same basic equation, that whatever the future value equation is or the present value equation. It doesn't matter if it's same thing with a simple annuity or a general annuity. The fact of the matter is, as we have this extra section added on, the 1 plus I has to be added on. And essentially, when we're talking about future value, we're saying, what is a value going to be worth at some point in time in the future? So if we make a series of payments, say 20 payments over 20 years of $100, how much is that going to be worth at the end of that period? That's what we're talking about with regards to future value. And in order to calculate future value, essentially what we have is a standard formula. It is the payment times 1 plus the interest rate to the power of n, and n relates to the number of payments or the number of items there, minus 1 over I. Now that's standard for future value, but for an annuity due, I'll call it an AD for short, what we have to do is we have to multiply that by 1 plus the I. So this is what we're going to be looking at in this particular section. And exercise 12.1, we'll look at a few problems dealing with the future value payments. Present value is really the present value of a series of payments. So let's assume that you're scheduled to receive a series of payments way into the future. And you want to say, instead of those series of payments, what if you paid me now? What if you paid me a lump sum amount now? So what present value does is it tries to look at that lump sum. So we're looking at annuities. So we're going to look at the present value of an annuity. And we're talking about annuities due. So let's take a look. So first of all, present value of an annuity is the sum of all present values. You could calculate the present value of every single payment and add them all up, and that will give you the same thing. in terms of an annuity due, the payments are made at beginning of a period. So let's assume that you're receiving a stream of payments, say 10 payments of $100. Well, essentially, the payment comes at the beginning of the month if the payments are monthly, let's say, for example, the beginning of the month. So this would indicate a present value when we try to figure out what is that worth today. And in terms of the present value formula, the present value formula, we found it to be PV equals the payment times 1 minus 1 plus I, the interest rate, to the minus n is the number of payments, divided by I. So that's the present value formula. And when we consider of annuity due, we multiply it, as I said, 1 plus I. So this little multiplication section gets added on. This would be for present value of an annuity due. The importance here is that we want to ensure, one of the things we need to do is we need to ensure that the payment begins at the beginning of the period. That's an annuity due. That's a certainty of an annuity due. And we are looking for the present value. What is it worth now? A stream of payments in the future. What are they worth now? Those are the couple of things we really need to look forward to. We also need to distinguish whether it is a simple annuity or a general annuity. And remember, from a simple annuity point of view, a simple annuity occurs when the payment and the compoundings are the same amount, the same rate. In other words, monthly and monthly, yearly and yearly. The general annuity occurs when they're different, a monthly payment and a yearly compounding. When we look at example set 12.2, it will help define some of the issues around the present value of an annuity due.